Hi everyone, and welcome to MathSux. This video is going to help you pass the Algebra Common Core Regents. So here is part 2. We're doing this one question at a time. Here is question 25. Is the product of radical 1024 and negative 3.4 rational or irrational? Explain your answer. So we know when we have the product, we're going to be multiplying. So we're multiplying radical 1024 times negative 3.4. So let's plug in our calculator. Let's see if this is a perfect square. I believe it is. So actually I just had it in here ready. Radical 1024 is equal to 32. 32 times negative 3.4. We could plug that in. And we'll just get negative 108.8. And so when we go back and look at the question they're asking us, they say, is this rational or irrational? Since this decimal is terminating, it ends, it's rational. Question 26. Describe the transformations performed on the graph of f of x equals x squared to obtain the graph of g of x when g of x is x minus 3 squared minus 4. So we're taking f of x equals x squared and making it g of x x minus 3 squared minus 4. So notice that we are subtracting 3 from x, which means we're transforming the entire graph and moving it over to the right 3 units. And if you look at what we're doing to the entire graph, x minus 3 squared, we're going to be moving it down across the entire y-axis, down 4 units. So this is all just based on function transformations. And I have a cheat sheet that goes into detail on how to do these, where whatever we're doing to h, it means we're going left or right on the x-axis, and then k is up or down on the y-axis. So that's how we get our answer. So just to write a little sentence to give an answer, we'll say that we moved right 3 units and down 4 units. Question 27. The total profit earned at a garage sale during the first 5 hours is modeled by the graph shown below. Determine the average rate of change, otherwise known as the slope, in dollars per hour over the interval 1 to 4. So when x is between 1 to 4, we want to find the slope. So let's look at x, the x-axis from 1 to 4. So we have 1. You could see it goes with this point 140, and then to 4. This corresponds to the point 4, comma 100. And what we're really doing is finding the slope between just these 2 points. So it's kind of like we're finding this line here. So to find this slope, remember that the slope formula is rise over run. The change in y over the change in x. So y2 minus y1 over x2 minus x1. So I'm going to just take these points that we just found and just plug them into the equation here. So we have, here's our x's, here's our y's, and just line them up to make sure that they follow along with each other. So we have 100 minus 40. So from this coordinate we've subtracted this one. And then we're going to do the same thing with the x's. So 4 minus 1. And we end up getting 60 over 3, which just gives us 20. And that's our answer. So we're just finding the slope. Question 28. Subtract 3x times x minus 2y from 6 times x squared minus xy and express your answer as a monomial. So we're going to be subtracting this from this. So that means we're going to have this order: 6 times x squared minus xy minus 3x times x minus 2y. So the tricky thing about when we have this minus sign is that we're going to want to distribute the minus sign and make sure we change our sign. So this part is going to stay the same. And now this is going to become 3x squared. So just multiplying 3x squared. And then minus 3x times minus 2y, distributing, we get plus 6xy. So let's now distribute everything on the left here. So we have 6 times x squared gives us 6x squared, and then 6 times minus xy gives us minus 6xy. And then just bringing down this section here, minus 3x squared plus 6xy. Okay, so now we can combine like terms. So notice we have 6x squared minus 3x squared. This will just give us 3x squared. And then we have minus 6xy plus 6xy, which actually they just cancel each other out. So we're left with the binomial they were looking for, 3x squared. Question 29. A function is graphed on the set of axes below. State the domain of this function. So the domain remembers all the x values. And if you look at the domain, you could see that there's arrows here which represent that this parabola is going to keep going on forever and ever and ever. So our x values are going to be all real numbers. Now, another part of this question asks to state the range of this function. So the range is all the y values. So if you look at our y-axis, we want to think about what goes along this graph, up and down. So if we're looking at this function, you could see that our values are going to keep going up and up and up forever, but notice that they stop right here, and they start and stop right here. So this value is 3. So y is greater than or equal to 3. So that's our answer. Question number 30. Solve 6x squared plus 5x minus 6 equals 0 algebraically for the exact value of x. Let's just rewrite the equation first. And notice we can't really do product sum here. We can't easily take out a GCF or anything. So what we're going to do is use the quadratic equation. So the quadratic equation is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So to plug in and use this formula, let's just write out what our a, b's, and c's are from our equation. So a is equal to 6, b is 5, and c is negative 6. So now let's just plug in all our numbers into our equation. So negative b is negative 5 plus or minus b squared, so that's 5 squared, which is 25, minus 4 times a, 6 times c, negative 6, all over 2 times a, which is 6. So to calculate this, I always like to calculate what's under the radical first, so let's do that. So we have 25 minus 4 times 6 times negative 6, which gives us 169. So we have negative 5 plus or minus radical 169 all over 12. So let's simplify this more. So what's radical 169? It's 13, so it's a perfect square. So we get negative 5 plus or minus 13 all over 12. So this gives us two equations. So x is equal to negative 5 plus 13 over 12, and x is equal to negative 5 minus 13 over 12. And now we just need to calculate each one and see what x is equal to. So we have negative 5 plus 13 divided by 12. This gives us 2/3. And now our other one, negative 5 minus 13 divided by 12, negative 3/2. So we get our answer, our multiple answers, x is equal to negative 3/2 and 2/3. This works out where both our answers apply to this equation, but always be sure to check and plug in what you get for x values back into the equation to make sure they work out well. Question 31. Factor the expression x to the fourth minus 36x squared completely. So first step, let's write it out. So the first thing we want to ask ourselves when factoring is, can I take out a GCF? So notice we can actually take out an x squared. So let's do that. So we have x squared, leaving us with an x squared inside, minus 36. So is there anything else we can do with this? Yes, there is. We can also do, so let me just write step 1, we did GCF. Step 2, now we can do difference of two squares, otherwise known as dots. So because this is perfect square and this is a perfect square, we can factor this super easy by doing something called a double bubble. We put a plus sign and a minus sign, and then we take the square root of each part of this expression here. So the square root of x squared is x, and then the square root of 36 is 6. So one more step, just to get rid of this x squared, we can make this x times x plus 6. So just bring the rest of this down, times x minus 6. And that's our answer. Question 32. Determine the exact value of x for x squared minus 8x minus 5 by completing the square. So when completing the square, the first thing we're going to want to do is add the whole number, in this case 5, to the other side of the equation. So we get x squared minus 8x equals 5. So you notice I left some space in between here. That's because we're going to be adding the same number to both sides. And what is this number? We're going to take this middle number, the b, divide it by 2. We'll get negative 4. We're going to square it and then get 16. And then this is the number we're going to be putting into our boxes. So now what we're going to do is rewrite the equation. So this whole thing can be summarized by writing x minus 4. And I got this minus 4 from right here, that number that we divided, negative 8 divided by 2. So we got negative 4, so that we brought that down here, squared. And then we just need to add these together. 16 plus 5 is 21. So now, okay, so we didn't just need to complete the square, but we actually need to find the values of x. So to find the values of x, we're going to have, I'm just going to rewrite this because we just completed the square. And now to get rid of this squared, we're going to take the square root, plus or minus square root actually. So we can get x minus 4 equals plus or minus radical 21. And then get x alone, we're just going to add 4 to both sides. And we get x is equal to 4 plus or minus radical 21. And that's our answer. Yeah, so the weird thing about completing the squares is, you know, there's a lot of tricky things to remember. There's a lot of weird rules, but when it comes to a test, you really just have to kind of practice these kinds of questions. And I have a bunch of practice questions on this if you want to practice completing the square, so you can check those out. Question 33. The graph below models the height of Sam's kite over a period of time. So we have time in minutes, and then the height of Sam's kite. Explain what the zeros of the graph represent in the context of the situation. So here we have a 0 over here, and another 0 over here. So the kite is at 0 feet. At 0 seconds at the beginning, it goes up in the air, and notice it comes back down and is at 0 feet again. So we can say that the kite is at 0 feet at the beginning and end of the flight. State the time intervals over which the height of the kite is increasing. So increasing, so we know that we're going to want our slope going that way. So notice that it's increasing from here to here and from here to here. So if we look at these time intervals, which is what they're asking for, it's from 0 to half a minute. and then from 1 to 2 minutes. State the maximum height in feet that the kite reaches. So if we look for the tallest part of the kite, it's up here, and if we go across to see what height this is, we can see this is 60. This is counting by 20, 40, and then 60. So 60 feet in the air. Question 34. On the set of axes below, graph f of x equals x squared minus 1 and g of x equals 3 to the x. So I'm just gonna make some tables for each function. So we have f of x equals x squared minus 1. So we could just plug these into the calculator. For f of x starting at -3, we get 8. And I'm just getting the table of values from over here for our x and y coordinates. So now when we graph this, we're just going to take coordinates from here. So -3, 8 is 1, 2, 3, and then up 8, 2, 3, 4, 5, 6, 7, 8. And now let's do g of x. Doing the same thing, so I'll plug this into our calculator. So we have 3 to the x. And notice we have these numbers that get very close to 0 but never get to 0. So let's just focus. So actually, let's graph a couple. So let's graph the same numbers, the same x values, and then we'll just copy over what we have here. So now when we go to our graph, we'll go to -3, and we'll see something very close to 0. -2, very close to 0. Again, -1, but that's a third. 0, 1. Okay, and 27 goes off the graph, so we can't really graph that. So this is forming this pattern, this exponential function here, g of x. Okay, so we graphed both functions. So now there's a follow-up question that asks, based on your graph, for how many values of x does f of x equal g of x? Explain your reasoning. So we want to know where they're equal, and we could see that they're equal at one point right here. So our reasoning is f of x and g of x intersect at one point. Question 35. An insurance agent is looking at records to determine if there is a relationship between a driver's age and a percentage of accidents caused by speeding. The table below shows his data. So we have age for the x values and percentage of accidents caused by speeding for the y values. State the linear regression equation that models the relationship between the driver's age x and the percentage of accidents caused by speeding y. Round all values to the nearest hundredth. So when we see we need to find the linear regression equation, we know we're going to be using our calculator and plugging in these values to find that. So this is just really a test in can you use technology well. So to do that, we're just going to go to Stat, go to Edit, so we press Enter. So I'm just clearing these so we can put this in. So now we're just going to plug in all the x values in the L1 column. So we did that. So now we'll just plug in the y values in the L2 column. Okay, so now that all our values are in, we're just going to go to Stat again, This time go over to calc and then go down to choice number 4, linear regression, ax plus b. And then we're going to press enter a couple times, and then we get our equation. So we have y equals ax plus b, where the a is equal to, so make sure we get it round to the nearest hundredth, so 0.96 tenth hundredth, and then b is equal to 64.74, rounding to the nearest hundredth. So we'll put this all together and we'll say y equals negative 0.96 x plus 64.74. And that's our answer for part 1 of this question. So the question also asks us, state the value of the correlation coefficient to the nearest hundredth. Explain what this means in the context of the problem. The correlation coefficient is just represented by this r here. So we want this to the nearest hundredth again. So we have r is equal to negative 0.98. So if you didn't have this r come up, just make sure you turn your diagnostics on by going to second catalog and then scrolling down to diagnostics. So this came up for me because I have it on, but if you don't have it working, be sure of that. So we have negative 0.98 is our correlation coefficient. And they want to know what this means in the context of the problem. So this means that the age of the person driving and percent of accidents caused by speed are inversely correlated to each other. So let's just write that out. And they're inversely correlated to each other. It's almost -1. It's a negative value and it's almost at 1. And that's our answer. Question 36. Solve the system of inequalities graphically on the set of axes below. Label the solution set S. So here, we have two inequalities. So the first thing I want to do is to get them in y equals mx plus b form. So even though we're dealing with inequalities, getting into this form as close as possible. So let's look at this first inequality here, 2x plus 3y less than 9. So to get y alone, we're just going to subtract 2x from both sides. So we get 3y less than negative 2x plus 9, and then divide 3. So we get y is less than negative 2/3 x plus 3. So that means our slope is going to be negative 2/3. So that means we're going to be going down 2 and to the right 3. And then our y-intercept for this inequality is 3. And since this is a less than quality, we know that we're going to be using a dotted line and open circles, because the values we find won't be included in the solution. So let's start with our y-intercept. Go to 3, 1, 2, 3, open circle, and then we're going to go down 2 and to the right 3. So 1, 2, 1, 2, 3, open circle, 1, 2, 1, 2, 3, open circle, and then we could go the other way. And remember, we're going to be using that dotted line. So since this is a less than sign, that means everything's going to be below the y-axis. So it's going to be down. We're going to have those negative y values. So we could shade that in. Okay, now let's focus on this inequality over here. We have 2y greater than or equal to 4x plus 6. So to get y alone, we'll just divide both sides by 2. And we're left with y is greater than or equal to 2x plus 3. So here we have our slope equals 2. So that means we'll be going up 2 and to the right 1. And our y-intercept is 3. since we have inequalities, this is greater than or equal to, so we're going to be using a solid line and closed circles. So let's start drawing this. So actually, I'm gonna draw this in purple. Okay, let's label our graph. This was 2x plus 3y less than 9. And now let's draw this one. So we have our y-intercept is 3. And then we have our slope, which is up 2 and over 1. So we have 1, 2, and over 1. And then the other way. And then we have we're going to be using a solid line because the solutions are included. And for shading, we're going greater than or equal to, so above this line, getting the positive y values. So now we have to find a solution. We're going to label the solution S. So notice that's where the solution is always where they overlap. So that's right here. So this is S. Okay. So now there's a follow-up question down below. It's asking us, determine if the point 0, 3 is a solution to the system of inequalities. Justify your answer. So if we go to 0, 3 right here, it might look like both inequalities include the solution, but see, this is an open circle, which means that it is not included. And that's why it's so important to keep track of open circles and closed circles. So 0, 3 is not in the solution. So 0, 3 is not in the solution because y is less than or equal to negative 2/3 x plus 3. This guy right here is less than and doesn't include this in the solution. I have a bunch of practice questions on graphing inequalities too, so please check that out. Our last question of the Regents, question 37. At an amusement park, the cost for an adult admission is A, and for a child the cost is C. For a group of 6 that included 2 children, so we have 2 children and leaving out of 6, so that means that there's 4 adults. The cost was $325. The total was $325.94. For a group of 5 that includes 3 children, so 3C, plus there's 5, so that means there's 2 left. 5 minus 3 times 2 adults, that cost was $256.95. All ticket prices include a tax. So the first question I kind of answered already. Write a system of equations in terms of A and C that models this situation. So I just wrote this knowing what the question was, but really just to organize my thoughts, and it ends up being the answer to this first question, where C represents the cost of children's tickets and A represents the cost of an adult ticket. So now we have a system of equations that we can work with. Part 2. Use your system of equations to determine the exact cost of each type of ticket algebraically. So let's bring these two equations down. There's so many different methods to use for these kinds of questions, but I'm going to use elimination, and to do that I'm just going to multiply this entire second equation by -2 to cancel this out, to cancel the a's out, because this will give us -4a, and here we have a positive 4a, so we can cancel them out. So I'm just going to bring this to the right, leaving this the same, the top equation. And now I'm just going to multiply -2 to each part of this second equation. And now we're just going to add these two equations together. -6 plus 2 will give us -4c. Notice the 4 A's cancel each other out. And then we have to add these two together, which gives us negative 187.96. Divide both sides by negative 4. And we get C is equal to 46.99. So we got the price of the children's ticket, but we still need to find the price of the adult ticket. So we could just plug this back into one of our equations. So let's just pick that first one and solve for the adult ticket price. So we get the adult price ticket is $57.99 and the children's ticket is $46.99. Okay, so our last part to the last question. Determine the cost for a group of 4 that includes 3 children. So that means there's going to be 3 children and 1 adult. So we know that 1 adult is $57.99 plus 3 children, so 3 times $46.99. So we have 3 times 46.99, and then we're adding 1 adult ticket, which is 57.99. And we get a total of 198.96, which is our answer. So this was our last question for the Algebra Regents. If you're studying for your test, I wish you good luck, happy studying, and happy calculating. So if you're looking for more on this test, check out the playlist in the link below. And thanks for stopping by. Happy calculating. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating.